Hydraulic Safety Shutdown Systems, Wellhead Control Panels, Localized Emergency Isolation and Remote Safety Assurance for Offshore Production. Hydraulic Safety Shutdown Systems, HSSS, integrated into wellhead control panels, provide vital safety interlocks in offshore production environments. These systems ensure rapid and failsafe closure of all critical wellhead and pipeline valves upon detection of unsafe process conditions or emergency triggers, either locally or remotely. The HSSS modules are compact, standalone, and ruggedized for harsh operating conditions, with modularity that enables fault isolation, ease of testing, and operational continuity across multi-string wellhead towers. Application scope. HSSS panels are installed on offshore wellhead towers to provide emergency shutdown ESD of subsurface safety valves, SSSV, DHV, surface safety valves, SSV and wing valves, Sealine Valves, SLV, interface with fire protection elements, fusible fire loops, panic buttons, local and remote operability through master telemetry interface modules, MTIM, telemetry interface modules, HIM, remote telemetry units, RTU. Their function is analogous to TERVs in being localized, autonomous protection units, but with multi-level control and far more critical process impact. Design characteristics. Modular construction. HPU, WCM, TM, and MTIM are housed in individual modules with full interchangeability across strings. Control drawers for each valve are plug-and-play type, promoting rapid replacement or servicing. Hydraulic segregation. Separate high-pressure HP, medium-pressure MP, and low-pressure LP circuits. Independent accumulators for each pressure regime to ensure continued actuation during power or supply loss. Pressure ratings: HP circuit 4500 psi GRAG set at 4800 psi, MP circuit 1500 psi set at 650 psi, LP circuit 50 psi set at 70 psi. Redundant operation: dual gas-driven pumps for both HP and MP circuits with 50% load sharing. Manual hand pump available for maintenance startup. Material and assembly standards. Construction materials: all wetted parts for sour gas service, Inconel 625, tubing Inconel 625, internal, and SS316L, external, hydraulic reservoirs and tanks, SS3116L with visual level indicators and corrosion-resistant design. Component certification: all instrumentation rated for Zone 1, Gas Group 2A IEB, temperature class T4, explosion-proof enclosures and cable glands to IP66 and C-Inelec EN 5001H 5019 standards. Installation guidelines: placement and orientation, mounted directly on wellhead tower with seismic vibration resistance, including helicopter landing impact. Hydraulic modules plinth mounted with anti-vibration pads. Interfacing: top entry hydraulic and pneumatic lines, bottom entry field signal cabling via pre-drilled gland plates, modular marshalling boxes with terminal blocks for field interconnects. Maintenance access: full height dual access panel doors, modular layout with front panel mounted controls and diagnostics. Operational features: local and remote control, local push buttons for each valve operation. RTU interface enables command execution and feedback from central control room, CCR. Sequenced valve operation, closure, WV, SSV, SSSV, SLV with adjustable 30s delay. Opening, reverse order failsafe logic, LP pressure loss triggers platform-wide shutdown. Fusible plug or panic button activation directly actuates valve closure. Diagnostic and testability, manual override with status feedback to CCR. Test modes with positive isolation and clear panel indication. Inspection and maintenance, visual and functional checks. Regular verification of pressure indicators, fluid levels, pilot valve actuation, and accumulator charge. Factory acceptance test, FAT, full hydraulic loop tests including NAS 1638 level 5 fluid cleanliness. Lock-in pressure integrity tests at working pressure for 60 minutes with 2% pressure loss. Site acceptance test, SAT, full system verification post-installation. Remote interface simulation via RTU and field loop checks. Summary: hydraulic safety shutdown systems in wellhead control panels provide autonomous, mechanically robust, and fault-tolerant safety infrastructure for offshore operations. By ensuring instantaneous shutdown upon signal loss, fire detection, or overpressure, HSSS delivers an uncompromising last line of defense. Its modular construction, remote integration, and adherence to stringent international safety codes make it indispensable in critical energy operations, providing both protection and peace of mind in unforgiving environments. HSS, sour gas system primary energy medium for hydraulic actuation in remote shutdown architecture. The sour gas system functions as the driving energy source for hydraulic actuation within the HSS. By converting high-pressure hydrocarbon gas into mechanical energy, it powers both the high-pressure HP and medium-pressure MP hydraulic pumps, which in turn supply the necessary pressure to actuate safety valves during normal operation and emergency shutdowns. Given the corrosive and hazardous nature of sour gas, this subsystem is designed with rigorous attention to material integrity, safety isolation, and pressure conditioning. TASHR application scope. The sour gas system is essential wherever no electrical power is available on the wellhead tower. Self-contained, maintenance minimal energy conversion is needed. Wet sour gas with H2S and chlorides is the only available utility fluid, typically deployed in remote unmanned offshore platforms, satellite wellhead towers, subsystems with solar or RTU-based telemetry, standalone hydraulic safety systems without diesel-driven power packs. Functional description. Gas source and pressure regulation. Sour gas is tapped from a separator tube off the export pipeline at pressures up to 2,500 psi. Dual pressure regulators in a saddle tank reduce this to 150 psi gray, adequate to drive hydraulic pumps without compromising downstream safety. Two-stage redundancy. Two pressure regulators operate at 100% capacity each, ensuring uninterrupted duty even during maintenance or failure. Saddle tank filled with lubricating oil provides thermal stabilization and contaminant isolation between sour gas and regulators. Thermal compensation. Tubing within the saddle tank is coiled to allow thermal exchange with lubricating oil, minimizing condensation or hydrate formation. HSS material and configuration features. Saddle tank assembly. Fabricated from SS316 with thermal insulation, glass fiber base, and an oil reservoir. Designed to mount on 8-inch separator piping or be freestanding. Includes drain valves, lift-off skirted covers with toggle fasteners, and integral bulkhead tubing connections. Pressure regulators, individually removable and serviceable without disturbing the saddle tank, installed with heat-conductive tubing coils for continuous duty in humid or marine climates. Materials of construction. All wetted components, NACE MRU 175 compliant for wet H2S resistance. Regulators and fittings, SS316 or Inconel 625, as required by service pressure and sour duty exposure. Safe safety and trip isolation gas block valve, SDV, hydraulically actuated and located immediately downstream of the scrubber. Trips automatically upon detection of high level in scrubber, abnormal pressure rise indicating regulator failure, controlled via master telemetry interface module for fast gas cutoff. Failsafe design. Any abnormality in pressure regulation, separator integrity, or level switch triggers immediate gas isolation, designed to prevent overfeeding of the hydraulic circuit with untreated or unregulated sour gas. Scrubber vessel integration gas scrubber functions. Removes entrained liquid and solids before gas enters the hydraulic pumps. Designed as vertical knockout pot with side entry inlet, demister screen, and top gas outlet. Instrumentation and safety devices, 2 pressure instruments, one for pre-alarm, electronic, one for shutdown, hydraulic pilot, 2 level switches, high level alarm to CCR, high level to trip the gas block valve, pressure relief and maintenance, equipped with dual 100% relief valves set at 150 psi, includes removable head or flange for internal inspection. Lifting davit incorporated for components 25 kilograms. Monitoring and control interface telemetry integration. Pressure and level statuses from the scrubber are transmitted to CCR via the TIM. Shutdown signals from pressure pilots are hydraulic and feed into the LP circuit of the master control module. Alarm and event logic. Any trip condition leads to isolation of sour gas via SDV, shutdown of hydraulic pumps, emergency actuation of valves across the HSS network. Summary. The sour gas system serves as the energetic backbone of offshore HSS installations, converting high-pressure, corrosive gas into clean, reliable hydraulic energy. Through redundancy and regulation, rigorous material specification, and embedded safety logic, the system ensures uninterrupted service while providing isolation on demand. When combined with high-integrity scrubbers, pilot signaling, and hydraulic trip interlocks, The sour gas system becomes a resilient, low-maintenance power unit engineered for the most challenging offshore environments. Hydraulic Power Unit, HPU, multi-pressure hydraulic generation for autonomous valve actuation in emergency shutdown systems. The Hydraulic Power Unit, HPU, is the central actuator energy source within the Hydraulic Safety Shutdown System, HSSS, supplying regulated high-pressure HP, medium pressure, MP, and low pressure, LP, hydraulic outputs required for reliable valve operations. Operating independently of electrical power, the HPU is driven by regulated sour gas pressure and is engineered to provide redundant, fail-safe, and uninterrupted hydraulic pressure to all critical shutdown components on remote wellhead towers. Functional role and integration. Core functions. Supplies HP hydraulic fluid to drive subsurface safety valves, SSSV, DHV. Delivers MP hydraulic fluid to actuate surface safety valves, SSV, WV, and Sealine Valves, SLV. Provides LP hydraulic control signals to pilot valves, relays, and interlocks. Integrates return lines and relief systems to manage hydraulic balance and contamination isolation. System isolation. HP, MP, and LP circuits are physically and functionally segregated with dedicated pumps, regulators, accumulators, and return lines. Pressure monitoring across all circuits enables remote supervision and automated trip logic through the TIM and RTU startup and emergency features. Manual hand pumps for both HP and MP circuits enable controlled actuation during startup or in the event of pump failure. Sufficient accumulator sizing ensures minimum 3 complete valve operations without live pump support. Mechanical design and construction. Skid and frame. Constructed on a C-section girder base with integrated structural framework. Base includes captive drip trays for early leak detection and fluid containment. Hydraulic reservoirs, fabricated from SS360L with 5 mm minimum thickness on sides and roof, 6 mm minimum thickness on base. Size to contain 2 times the total hydraulic fluid volume required for accumulators, wellhead valve actuators, SSSV, SSV, SLV. Hydraulic control lines, fusible loop, and panic button circuits. Dump tank, minimum 10-gallon capacity, high-level switch for overflow protection, designed with drainage and inspection points for contamination monitoring, linked to main reservoir for flushing and return. Vent and relief systems, common relief header with flame arrestor for both reservoir and dump tank, sight glasses for both tanks, breather valves vented externally for safe gas handling. Circuit pressure parameters. Each hydraulic circuit is individually configured with its own working, set, and monitoring pressure levels. High pressure, HP, working pressure, 4,500 psi, set pressure, 4,800 psi, monitoring range, 0 to 6,000 psi, medium pressure, MP, working pressure, 1,500 psi gram, set pressure, 1,650 psi gram, monitoring range, 0 to 2,000 psi gauge, low pressure, LP, working pressure 50 psi, set pressure 70 psi gauge, monitoring range 0 to 100 psi gauge. All circuits are monitored with glycerine-filled pressure gauges, and critical points are equipped with pulsation dampers to ensure reliable readings under dynamic load conditions. Pumping mechanism and redundancy gas-driven pumps, 2 pumps per HP and MP circuit, driven by sour gas at 150 psi gauge. Normal operation involves load sharing. Each pump runs at 50%. Upon failure of one pump, the other automatically assumes 100% load. Filtration and safety. Suction through paired fine strainers, 5 to 10 microns. Discharge equipped with check valves, fine filters, relief valves to protect downstream components. Accumulator support. Bladder piston type accumulators pre-charged with nitrogen, sized for at least 3 full valve operations in the absence of pump pressure. Mounted securely on the skid frame. Compliant with BS 5500 or ASME standards. Relief valves installed for accumulator overpressure protection. Summary: the hydraulic power unit is the operational nucleus of the hydraulic safety shutdown system, ensuring that safety valves can respond instantly to emergencies, even in the absence of power or operator intervention. With isolated circuits, redundant energy sources, field-proven gas-driven pumps, and precision pressure control across HP, MP, and LP lines, the HPU transforms raw energy into dependable actuation force. Its modular construction, rigorous material specification, and intelligent design safeguards offer long-life performance and system integrity in the most remote and demanding offshore environments. Tesh Well Control Module WCM, Modularized Hydraulic Command Center for Valve Control and Shutdown Execution. The Well Control Module WCM serves as the localized control core within the Hydraulic Safety Shutdown System, HSSS, executing precise hydraulic operations to actuate all critical wellhead valves. Each WCM is tailored per production string and enables independent control, monitoring, and shutdown of subsurface safety valves, SSSV, DHV, surface safety valves, SSV and WV, and Sealine Valves, SLV. Engineered with a drawer-based modular architecture, the WCM ensures ease of maintenance, fail-safe operation, and full compatibility with local and remote command signals. Functional purpose and control logic. Per-string control architecture. Each well string is provided with a dedicated set of drawers within the WCM. Drawer 1 controls HP hydraulic circuit to subsurface safety valve, SSSV DHV. Drawer 2 controls MP hydraulic circuit to surface safety valve, SSV. Drawer 3 controls MP hydraulic circuit to wing valve, WV. Sealine valve integration. A separate module or drawer is dedicated to SLV operation using MP hydraulic supply, shares common logic and control components with wellhead valve drawers. Operational control signal routing via pilot and relay valves actuated through LP hydraulic logic. Manual and remote operation modes available with full interlock protection. Construction and layout features. Drawer-based modular design. Pull-out drawers for each valve circuit ensure quick service access, interchangeability across strings, functionally and structurally identical layouts. Panel arrangement. Local monitoring and control components mounted on front face. Hydraulic routing and logic housed within drawer interior. Spare drawers included for future well strings, e.g. 2 spares for ZK35. Hydraulic routing. Each valve has a dedicated pressure regulator with return routed to corresponding header, HP, MP, LP. Integrated check valves and block valves for isolation during maintenance or testing. Control and monitoring interface. Integrated local controls, pressure gauges for supply pressure, control line pressure, push buttons for opening and closing of each valve, SSSV, SSV, WV, SLV. Status indicators for high-low pressure pilot signals, valve open-close positions. Manual overrides, available for each valve with lockable test and override functions. Status transmission to CCR for remote visibility. Override features designed with safety interlocks to prevent inadvertent operation. Interlocks and safety logic, hydraulic interlocking to prevent conflicting valve states. Shutdown reset provision included for DHV and SLV via local push buttons. All manual test and reset actions require safety confirmation and feedback to master telemetry interface MIS, scalability and expansion provisions. Spare capacity. 20% panel space reserved for future valve expansions. Additional drawers included for planned string growth. Modularity benefits. Plug-and-play drawer replacement reduces downtime. Uniformity in control logic simplifies operator training and troubleshooting. Enables isolation of individual string without impacting others. Summary. The Well Control Module, WCM, is the tactical execution point of the hydraulic safety shutdown system, converting hydraulic logic into valve movement with precision and safety assurance. Through its standardized modular drawers, it offers flexibility in configuration, ease of expansion, and critical fail-safe operation for each well string. With built-in manual override, remote actuation compatibility, and full diagnostic visibility, the WCM empowers both local personnel and centralized operators with dependable control over vital shutdown assets, ensuring safety and continuity in offshore production environments. Master Telemetry Interface Module, MTIM, or Master Control Module, Centralized Emergency Logic Processing and Shutdown Initiation Hub for HSS. The Master Telemetry Interface Module, HIM, also referred to as the Master Control Module in some configurations, functions as the central decision-making unit of the Hydraulic Safety Shutdown System, HSSS. It processes platform-wide emergency inputs such as fusible loop activation, panic button triggers, or pressure anomalies, and initiates immediate shutdown sequences. Strategically integrated into the hydraulic power unit HPU enclosure, the MTIM ensures that all shutdown commands are prioritized, routed, and executed via low-pressure hydraulic signaling across connected well strings. Functional role and safety architecture shutdown decision node acts as the primary interface between the central control room, CCR, and the wellhead modules. Receives LP hydraulic signals from field inputs, fusible loops, panic buttons, pressure pilots. Remote shutdown commands from CCR via the telemetry interface module, TIM. Failsafe logic core triggers complete well shutdown upon LP pressure loss. Sends LP trip signal to well control modules, WCMs for closure of DHV, SSV, WV, Sealine valve module for SLV isolation. Integrated safety functions. Common manual reset lockout valve for emergency inputs. Built-in logic ensures valve closure without reliance on electrical power or operator intervention. Monitoring and control interface. Local instrumentation and display, front panel mounted gauges and indicators for LP hydraulic pressure status, control signal pressures routed to each string module, HP and MP supply pressures, active status of fusible loops and panic button circuits. Emergency input supervision, monitors, high pressure level in scrubber, pilot pressure loss on SLV and Sealine circuits, integrity of LP signal distribution, remote alarm relay signals sent to CCR upon activation or loss. Test and diagnostic access, manual test provisions included for LP shutdown logic, solenoid control valve functionality, clear panel indicators for operation mode, test mode with status feedback to CCR. Shutdown control sequence valve closure sequence upon emergency. 1. Wing valve, WV. 2. Surface safety valve, SSV. 3. Subsurface safety valve, SSSV, DHV. 4. Sealine valve, SLV, delayed by 30 seconds, adjustable timer. Valve opening sequence after safe reset. 1. Subsurface safety valve, SSS DHV. 2. Surface safety valve, SSV. 3. Wing valve, WV. 4. Sealine valve, SLV. Local remote control modes. Wing valve and SLV open-close from both CCR and local panel. SSV and SSSV primarily controlled locally with CCR feedback monitoring. Safety and redundancy features. Signal integrity design. LP tripping signal is hydraulic, immune to electrical failure. Manual reset lockouts prevent inadvertent repressurization of tripped circuits. Trip signal broadcast to all valve modules simultaneously for coordinated shutdown. Isolation and maintainability. MTIM allows maintenance of individual field modules without affecting system-wide shutdown capability. Hydraulic isolation valves and test points integrated for safe maintenance procedures. Summary. The Master Telemetry Interface Module is the strategic nerve center of the HSS, executing intelligent safety logic to ensure rapid, coordinated valve shutdown in response to emergency conditions. By consolidating platform-wide shutdown commands and distributing LP trip signals to all dependent systems, the MTM ensures that even isolated or unmanned towers retain complete protection. Its hardened hydraulic logic, embedded testability, and fail-safe sequencing architecture make it a critical layer of defense in offshore production safety, guaranteeing system responsiveness, operational clarity, and shutdown integrity. Attached Telemetry Interface Module, TIM, signal bridge between hydraulic safety logic and remote monitoring systems. The Telemetry Interface Module, TIM, serves as the essential communication and interfacing hub between the Hydraulic Safety Shutdown System, HSS, and the Central Control Room, CCR. Designed to integrate signal processing, relay actuation, and remote command execution, the TIM enables real-time supervisory control over critical shutdown functions while maintaining complete local autonomy. Positioned on each wellhead tower, the TIM ensures secure bidirectional communication between field instrumentation and remote telemetry units, RTUs. Functional role and communication architecture. Remote actuation control executes remote commands for opening and closing of wing valves, WV, opening and closing of Sealine valves, SLV. Each valve control includes one solenoid valve for opening, one solenoid valve for closing. Shutdown signal processing receives remote emergency shutdown, ESD signals from CCR, transmits these to the MTIM for coordinated shutdown across all WCMs. Signal distribution and feedback collects and transmits field instrument statuses to CCR via RTU, including valve position signals, pressure switch statuses, override conditions, alarm conditions, e.g. pilot failure, pressure loss, fire activation, operational features, and overrides. Solenoid valve control. 3/2-way, direct-acting pulse-type solenoid valves, pulse duration 0.5 to 5.0 seconds, configurable via RTU. Flame-proof, vibration-resistant design with IP66 ingress protection. Manual override functionality. Wing valve and SLV override switches provided for startup, testing, maintenance. Safety interlocks prevent inadvertent actuation. Override status transmitted back to CCR for supervisory awareness. Position and status indication. Inductive proximity switches used for open and closed valve positions, override activation states. Hermetically sealed design eliminates false signals due to vibration. Signal interfacing and cabling. Wiring and termination. Internal marshalling via explosion-proof FRP junction boxes. All electrical signals terminate at EXE certified terminal CLEC EN 5019. Terminal blocks, Weidmuller type 2.5 millimeters rated with 20% spare capacity. Cable entry management, hydraulic pneumatic connections, top entry, electrical signal cables, bottom entry via removable gland plates, all glands dual certified for hazardous areas, EXD and EEXE. Internal wiring, solenoid circuits, 2.5 millimeters squatter tin copper, CSP insulation, signal circuits, 1.0 millimeter tin copper, all wiring flame retardant to IEC 60332. Field signal integration, connected instruments and inputs, pressure switches for DHV, HP, MP, LP headers, fusible loops, panic buttons, scrubber input instrumentation, high and high level switches, high and high pressure switches. Alarm routing. All fault or trip conditions generate volt-free contacts for RTU input. Alarms displayed in CCR with descriptive tag names and associated string. Summary. The Telemetry Interface Module, TIM, is the digital command relay of the HSS, translating hydraulic field conditions into actionable data for remote operators and vice versa. By coordinating valve actuation through dedicated solenoid paths and managing field input signal integrity, the TIM enables seamless control from the CCR while safeguarding local autonomy. Its robust design, configurable logic, and high-integrity wiring practices make it indispensable for real-time decision-making, remote diagnostics, and intelligent shutdown enforcement in offshore safety operations. Tashtar panel construction, engineered enclosures for harsh offshore environments and safe hydraulic integration. The panel construction for Hydraulic Safety Shutdown System, HSSS modules, including the Well Control Module, WCM, Master Telemetry Interface Module, MTM, and Telemetry Interface Module, TIM, is specifically designed for long-term durability, accessibility, and protection in offshore operating environments. These enclosures house hydraulic and electrical components in structurally isolated sections, enabling safe, efficient operation, maintenance, and troubleshooting under hazardous and corrosive conditions. Structural design features. Materials and build. Internal cabinet frames constructed from SS316L stainless steel. Outer protective shell made of UV-resistant fiber-reinforced plastic, FRP. Full seam welded drip trays integrated at the panel base with manual drain valves for fluid containment and spill detection. Access and maintenance. Full height, front and rear doors with lift-off hinges for unrestricted access to components. Doors are weather-tight and dust-tight, sealed to meet IP66 ingress protection, equipped with mechanical bracing to eliminate flex during door operation. Handling and installation, panels fitted with certified lifting paydies for crane transport. Proof load testing and non-destructive testing, NDT, conducted on all paydi welds. 100% magnetic particle inspection, MPI, for welds. 100% ultrasonic testing, UT, for full penetration joints. Post-load MPI for final validation. Environmental and hazardous area compliance. Ingress and flame protection. All panel assemblies meet IP66 enclosure rating as per IEC 6529, certified for Zone 1, Gas Group 2A IB, temperature class T4 environments. Internal instruments and field devices are EXD flameproof or EXE increased safety rated in compliance with CNLX standards, EN 5018 and EN 5019. Vibration resistance, anti-vibration pads installed between base channel and cabinet body, withstands mechanical disturbance from nearby activities such as helicopter landings. Internal layout and segregation, dual compartment configuration. Panels are divided into two functional zones: hydraulic section, all tubing, regulators, pilot valves, and block valves. Electrical section, cabling, terminal blocks, signal processing components. Instrument mounting, all control instruments flush mounted on the front panel for clear visibility, operator accessibility, minimized ingress risk. Hydraulic connectivity, Tubing routed to bulkhead-mounted terminal fittings for seamless module-to-module integration. All top entry for hydraulic and pneumatic lines to maintain seal integrity. Proper spacing and clipping using polytube brackets to avoid tubing contact or stress. Electrical cable management. Cabling and termination. Bottom entry for all instrumentation and signal cables. Removable gland plates pre-installed for flexible field connection. Internal wiring uses 2.5 millimeter squares tinned copper for solenoid and high power circuits. 1.0 millimeters tinned copper for signal and status loops. Flame retardant insulation per IEC 6332. Voltage rating for all cables 300 volts, 500 volts. Junction boxes and terminals. Marshalling boxes constructed from FRP with stainless steel hardware. Terminal blocks, wide Miller type with end plates, labels, and 20% spare capacity. Cable entries, ISO M20 thread size, dual certified for hazardous use. Safety and usability enhancements. Ergonomics and operator aids. Push buttons and hand switches on shutdown circuits are red colored with lift-up safety flaps. All valves and switches clearly labeled with engraved stainless steel nameplates. Internal document holders included in panel doors for quick reference to circuit diagrams and operational data. Grounding and bonding. Tapped and fully welded earth bosses on opposite panel sides. All instruments and marshalling boxes directly bonded using minimum 4.0 millimeter square tinned copper earth wires. Summary. Panel construction in the HSSS framework is more than an enclosure. It is a protective, operational, and diagnostic environment built to endure offshore rigors. By combining corrosion-resistant materials, segregated functional zoning, certified hazardous area compliance, and thoughtful human factor design, these panels act as hardened process interfaces. Whether enabling hydraulic flow, responding to emergency signals, or hosting field diagnostics, their robust construction is fundamental to the reliable execution of safety logic in remote and critical wellhead environments. TASH hazardous area classification, ingress protection, explosion-proof assurance, and environmental shielding for offshore safety equipment. All components and enclosures of the Hydraulic Safety Shutdown System, HSSS, including the Hydraulic Power Unit, HPU, Well Control Modules, WCM, Master Telemetry Interface Module, MTIM, and Telemetry Interface Module, TIM, are engineered and certified for deployment in classified hazardous areas. These certifications ensure continuous safety, integrity, and operational readiness in offshore oil and gas environments characterized by explosive gas mixtures, high humidity, and corrosive atmospheres. Area classification compliance, designated hazard zone. All modules and field-mounted components are suitable for use in Zone 1 hazardous areas, gas group 2A and IB, temperature class T4, 105. Certifying standards and agencies, equipment certifications issued by internationally recognized bodies such as BASIFA, British Approval Service for Electrical Equipment in Flammable Atmospheres, PTB, Physikalische Technische Bundesanstalt, Germany, FM, Factory Mutual, USA. Compliance with CNLECI EN 5014, EN 5118, EN 5019, IEC 6079 series for explosive gas atmospheres. Ingress protection standards enclosure ratings. All equipment enclosures, panels, and marshalling boxes conform to IP66 ingress protection per IEC 6U529. Guarantees complete protection against dust ingress, high-pressure water jets, marine spray, and offshore salt mist. Sealing and mounting integrity. Gaskets, cable glands, and panel joints are tested for seal durability under pressure, vibration, and thermal cycling. Dual certified cable glands rated for EEXD, flameproof, EEXE, increased safety. Field instrumentation requirements, certified component specifications, all analog digital field instruments, including solenoid valves, pressure switches, proximity limit switches, level switches, must be explosion-proof, EEXD, rated for continuous operation in Zone 1, 2A, IIB, T4 environment, weatherproof to IP66 minimum. Material selection for corrosive exposure, external hardware and instrument housings made of SS36L or FRP UV resistant, selected for corrosion resistance to marine and hydrogen sulfide H2S exposure. All instrument labels and fasteners are made of stainless steel to prevent galvanic corrosion. Cabling and connection safety, cable entry and routing. All cable entries equipped with flame-proof cable glands, threaded ISO M20 entries, gland plates with spare entries, minimum 20% spare capacity. Bottom entry for signal cables. Top entry for hydraulic tubing ensures signal isolation and moisture protection. Junction box certification, marshalling and terminal boxes constructed from FRP or cast aluminum, internally bonded and sealed, certified to EEXE standards with high mechanical strength. Summary. The HSSS Hazardous Area Compliance Framework ensures that every component operates safely and reliably in potentially explosive offshore environments. With IP66 ingress protection, certified flame-proof design, and robust material selection, each module and device is fortified against ignition risks, environmental intrusion, and long-term corrosion. These design safeguards ensure that safety-critical functions like valve shutdown, panic signal processing, and remote communication remain dependable under extreme operational conditions, forming the bedrock of process safety and personnel protection on offshore wellhead installations. STASH, field and internal equipment precision devices for hydraulic control, feedback, and emergency actuation. The Hydraulic Safety Shutdown System, HSSS, relies on a carefully selected suite of field and internal instrumentation to execute and monitor hydraulic logic across all wellhead safety functions. These components, ranging from pressure switches to panic buttons, are chosen for their reliability, responsiveness, and certification for hazardous offshore environments. Installed across well control modules, WCMs, master control modules, MTM, and telemetry interface modules, TIMs, they form the core functional layer for shutdown initiation, valve actuation, and signal feedback to the central control room, CCR. Chashastar pressure switches function, monitor hydraulic and gas pressures, trigger alarms, or shutdown logic upon deviation. Type SPDT, single pole double throw, micro switch based, contact rating 24 VDC, 1A switching differential, -2%, integral junction box, weatherproof with ISO M20 entries, application, HP, MP, and LP header pressure, fusible plug status, panic button circuit integrity, pressure pilot feedback, well strings, and sealing valve. Pressure gauges function. Provide local visual feedback of hydraulic and gas pressures. Construction, SS316L body, SS316 internals. Dial size 2.5 inch for HPU and TIM panels, 6 inch for gas scrubber. Scale, dual scale in Barg and Saigon white dial background. Accuracy, Placid 1%. Features, glycerin-filled blowout protection, laminated glass window, integral gauge adapters, and Inconel 625 manifold with old NPT connection. Pressure pilots function, hydraulic trip initiation on pressure deviation, block and bleed configuration. Type, spring-loaded piston, adjustable trip set point. Process connection, half-inch NPTM, signal connection, quarter-inch. NPTF features, visual trip indication, wetted parts, Inconel 625, compliance, NACE MR 175, sour service. Fusible loops function, fire detection and emergency shutdown actuation. Type, fusible plugs or plastic thermal tubes. Actuation temperature, 184 degree fries to 200 degree fry. Construction, SS316 body with lead fuse. Connection, quarter-inch NPTM. Panic buttons function, manual emergency shutdown activation by personnel. Design, three-way ball valve push and release type. Connection, quarter-inch NPTF, material SS36L, labeling, engraved SS316L plate marked action required to operate. Block valves function, hydraulic isolation and shutoff in gas supply or valve actuation lines. Actuation, hydraulic spring return actuator. Construction, valve body, carbon steel ASTM A105, control add-ons, adjustable flow regulator, quick exhaust valve test port, cylinder, corrosion inhibited level switches function, monitor hydraulic reservoir and scrubber levels for alarms and shutdowns. Types, float or displacer for process service, DP type with SS3 and 16L bellows for reservoir level. Features, 2 sets of SPDT snap action contacts, 2NO plus 2NC, 24 VDC, 1A rating, integral junction box, no flying leads, switch differential, ISO 2%, hermetically sealed contacts. Solenoid valves, SOVs function, remote hydraulic control for WV and SLV actuation. Design, pulse type, 0.5 sec, RTU configurable, direct acting, 3 halfway, normally de-energized. Coil, 24 VDC, class H insulation, 100 degrees Celsius, continuous duty. Housing, SS316 body, painted, flame-proof, EXD, IP66 ingress protection with built-in terminal junction box, no flying leads. Tiled limit switches function, valve open close and override position indication. Type, inductive proximity switch, hermetically sealed. Mounting, actuator mounted, unaffected by vibration. Output, chatter-free signal using distance differential protection. Enclosure, IP66 weatherproof SS316L junction box with ISO M20 cable entry. Mechanical switches not permitted. Tag tubing and fittings function. Connect and route hydraulic signals reliably across modules and field devices. Materials, process lines, SS904L with 2mm PVC sheath. Internal HPU tubing, Inconel 625. External hydraulic lines, SS316L with PVC sheath. Dimensions, 1/4 inch OD. Wall thickness, 0.085 inch, 0.65 inch, 1/4 inch. Fittings, double ferrule, flareless type, gyrolock or equivalent, all compatible with NACE MR0175. Tubing supports imperial polytube brackets with isolation from structural contact. Summary. The field and internal equipment of the HSSS form a tightly integrated ecosystem of detection, control, and response. Each component is selected not just for performance, but for its resilience to vibration, corrosion, and explosive atmospheres. Whether detecting a fire, initiating an emergency trip, or providing visual status to operators, these instruments are vital sentinels in the safety chain. Their rugged design, field-proven reliability, and precise interface with hydraulic logic ensure that every shutdown signal is transmitted, received, and acted upon without delay, upholding the safety integrity of offshore wellhead operations.